Welcome back. Today we're going to be talking about analyzing scatter plots. So let's go ahead and get started with that by taking a look at the introduction. So here we have a couple of reminders about scatter plots. Scatter plots show a relationship, and the data in a scatter plot must be quantitative. This means the values must be numbers. Scatter plots show us trends and help us make predictions, but scatter plots do not show us causality, which means we can't take a look at something and say, yes, because of this, it absolutely happens. That's what causality is. Scatter plots can't do that. They can show us trends, they can show us predictions, things we might happen or things that might be related, but we can't say because of this, this happens. Now let's take a look at the 4 types of trends we can see. So here we are talking about correlation. Correlation describes the relationship between 2 variables. And you can see here that we have 4 different types of correlations. So the first one is a positive correlation, whereas x increases, y increases, and you can see that our dots are going up and to the right. A negative correlation, whereas x increases, y decreases, so you can see our dots are going down and to the right. A constant correlation, whereas x increases, y is constant, so our dots kind of go in a straight line with each other. And then no correlation, where x and y do not have a relationship and our dots are kind of all over the place. Now let's take a look at these correlations applied in example A. So here in example A, it says the scatter plot shows the relationship between Trey's age and the time it took him to run the mile. We're going to answer the questions that they've given us. So the first question is, what is the correlation of this graph? So we have 4 correlations: positive, negative, constant, and none. And if we're taking a look at our graph here, we can see, although it is very slight, it's going down very slowly, but it is going down as we go from one side to the other. So it's going down, it's showing a negative correlation, right? As our x increases, our y decreases. So as Trey's age increases, his mile time, as we just talked about, decreases. So the older he's getting, the faster he's running. How many years did Trey track this information? For that, all we have to do is count up the dots. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So he tracked this information for 8 years. And then the last question is, Trey wants to predict. Now again, we talked about scatter plots we used in order to make predictions. Trey wants to predict his mile time for the age of 45. Should he use this graph? And justify your answers. So for us, we're going to determine, well, could he use this to predict his age of 45? And as most of us know, the older we get, stronger, bigger, the faster we can run, but that's not going to be forever, right? The older you get, eventually you get older to the point where you begin to lose speed, begin to slow down. So, no, while his time in the mile will decrease, we all agree with that, when he gets older, it will not decrease forever. So this graph is showing a consistent decreasing, right? But we can't say that that's going to take place forever, because by the time he's 45, he's probably not going to run at the same speed as he did when he was 22, or even when he was 18. Now let's take a look at another tool we can use to help us make predictions. So the tool that we have here is the line of best fit. A line of best fit helps us in making interpretations and predictions about the situation modeled in the set of data. So this is a tool that we can use to make predictions. It doesn't mean that it's going to be 100% accurate. It's just something that we're going to use to help us understand and interpret the data. So, using the line of best fit, the questions we have before us predict how much gas will be needed to drive 400 miles, and using the line of best fit, predict how many miles can be driven on 4 gallons of gas. Now, it's very important that we see the question tells us to use the line of best fit. So we can approximate without the line of best fit, but because the question tells us to use the line of best fit, we must use it when answering the question. So using the line of best fit, predict how much gas will be needed to drive 400 miles. So we're going to go over to 400 miles and we're going to go up until we hit that line of best fit. And in this case, we can see the line of best fit lands between 16 and 17, so how many, or 16 and 18, so our answer is going to be 17 gallons. Now we need to use the line of best fit in order to predict how many miles can be driven on 4 gallons of gas. So we're going to go over to the 4 gallons of gas, and we're going to go over until we hit the line of best fit, which is at 100. So 100 miles is the amount that we have. Now notice that in our scatter plot, none of our dots were on 100. None of our dots were on 17 gallons. We're not looking for one of the dots to be there. We're using the line of best fit. So it's very important that we read what the question asks us in order to be able to answer the question. Now let's take a look at example B. So here in example B, we need to answer 4 questions using this table. So it says the table represents the sales data of a small business. So using the graph, what trend can we observe in the afternoon? Using this graph, what 2 hours is better to have less staff available? When using the graph, what trend can we observe in the evening? And why is it important to recognize trends in this set of data? So using the graph, what trend can we observe in the afternoon? So if we're looking in the afternoon hours, we can see that as it's going along, our dots are going down and to the right in the afternoon. So between 1 and 5 in the afternoon there, we can see that we have a negative trend or a negative correlation. Then, using the graph, what 2 hours is better to have less staff available? So we want to make sure that we're optimizing our staff here. So we want to know when it's better to have less staff available, and that's when there's going to be less people in the store. So we're going to look for a section of our data where there are the least amount of people in the store, and that's around this down here where we have the least amount of dots. That's going to be between 5 and 6 p.m. Then it says, using the graph, what trend can we observe in the evening? So you can see that our data is going down in the afternoon, then picks up in the evening. So in this store, it's probably that less people start to arrive around dinner time, and then once dinner is over, more people come back to shop. So using the graph, what trend can we observe in the evening? We can see that in the evening, our dots are going up and to the right. So for the evening, we have a positive trend. And then why is it important to recognize trends of data, especially in this store? Well, it's very important as a business owner that you make sure that you have the number of staff available when you need them for when you have a lot of people in the store, and also that you don't have too many staff members in the store when there aren't a lot of people there. That would not be financially savvy to have a bunch of employees standing around not really doing anything. So it's important because you need to deploy your staff for both supporting customers and not to waste resources. So you want to make sure that you have people in the store when you need them there, and when there aren't a lot of customers in the store, you don't have a lot of people there. That brings us to the end of this set of notes. It also brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will see you in the next one.